Yeah, so, my name's Susanne.
Yeah, I'm Stefan, and we're working at an automotive supplier company, which has been doing software for automotive for some time. As you can see, some major brands. Let's get to the next slide. And we are working in one domain. We have in different domains like navigation and so on, but I won't talk about this right now. We are working in the domain which deals with electronic control units. And electronic control units, you can see one on the right-hand side. It's a rain and light sensor, so a very simple device to control your windshield wipers if there's rain. So these are very, very tiny devices. So in the past, so is, for example, if we talk about the basic software running there, which we developed, so this is about 150,000 lines of code. And we've roughly been developing this for 10 years now with about 50 developers. So this is, if you talk about the code that runs on the device, this is about 300 lines of code per developer. So very small. We know every bit. And we're doing updates only in the garage. So, but let's get to the next slide. There is some rules we have to stick to, in this domain. Like SPICE, MISRA, which is the C rules, and ISO 26262. It's about functional safety, a very hot topic at the moment. And currently, if you look at cars that are here in the field nowadays, they have large networks of maybe 60 plus electronic control units for motor control, for braking, for power steering, and so on. But we still are in this domain where we know each bit and each line of code. And there is no unused code. And for example, our operating system is highly configurable, and it will generate code which is optimized according to the configuration.
Yeah, and one key thing here is that when you have all these systems in a car, then you have suppliers working together. And all these standards had been invented because people thought this is how we need to organize the collaboration of a lot of people. And so.
Okay, so the big question is, how does this domain, this is electronic control unit domain, go together with open source?
So, and open source got into it, many of you will know that, because, I mean, first people used open source tools like Perl or like Python and Make to generate code. And so on the code generation side, they started doing open source, and then they realized, oh, there are cool libraries that we could use inside the car. And then the fun began.
Okay, I've already mentioned MISRA. MISRA is a guideline for C programming. And there are a few odds and ends to it. Like, for example, there's one rule, which means basically you must not use goto. On the right-hand side, you can see this is one function from the Linux kernel. And so goto is out there. And another of my very favorite rules from MISRA is you must not use pointer arithmetics, and the only valid form is array indexing. And of course, if you look at the Linux kernels, then you're totally out. And the problem in this domain is that there's a strong belief that you must not have MISRA violations. A MISRA violation is treated equally as a bug. So if you look at just this function, so this is according to the point of view of the automotive domain, this is really buggy software. And once upon a time, an organization what was interested in using the Linux kernel
Let's
in
call
this
it
domain. Yeah, thanks. And they have applied a MISRA tool, a MISRA checker to the Linux kernel. And you must note, these MISRA checkers are really expensive stuff. So you've got 5-digit euros per annual license for this tool. And they thought, oh, yeah, let's apply this. And of course, they got millions of bugs that they found. And they thought, well, we've got this community and we are doing them a big favor. We have this report here with all these bugs, these millions of bugs. We give it to them. They will certainly start fixing right away. So you can imagine what happened. Okay. Another thing is, if you're talking about the automotive domain, we're talking about SPICE and about processes. On the right-hand side, you can see one thing that is always together with SPICE, that's the V model. if you look at the left-hand side of the V model, this very much looks like a waterfall model. And you need to do all of the stuff at the top down to the bottom before you can even start with the implementation. So once again, a big question, does this work for open source projects? We have got the code first.
Yeah.
Okay, finally, there's also legal aspects involved. And I just start with another funny story. Maybe some of the elder ones of you still remember SEO versus Unix. So back in the days, this made quite some waves. And it even hit legal departments of automotive suppliers. They heard about this and open source software, and oh, there are lawsuits going on. And I was forwarded one mail from a legal department back in 2005 or 2006, I don't remember exactly, and it stated pretty much, you must not use any open source software in all of your project. You must cease to use it immediately until there is clearance from the board of directors.
Yeah, and that was also in all departments, also in the tooling anywhere. So, but times have changed. So anyhow, what's also a thing is that, and that is actually something that we need to work with the open source community on. So GPL3 has these anti-trivialization clauses where they say, okay, we want to be able, if you buy a device and there's open source software, free software in there, you should have the freedom to modify the device. So now I buy a car, and then I buy, in that car there's a steering control, and do I want every mechanic to be able to modify the steering control? Not sure, you know, because then the car manufacturer can blame the mechanic and can say, anybody could have modified your car. We don't know, we're out of the game. So for liability reasons, you need to have secure boot on such things, and that is an area of tension. I don't have a solution, but it's a problem. And then also inside the company, you know, they come from patents and they come from the intellectual property world. And you go out there and you say, folks, we need a community license agreement to be signed. And we need to have clearance for our engineers to just contribute. We can't have every single patch reviewed. So this is painful inside the companies, but it's making slow progress. And then you also have to follow the rules and make the proper attribution for licenses. So when you own your car, that you click in there and that you realize, oh, in the engine, there is some BSD software and these are the authors. But anyhow, this exclamation mark is important. We want to have open source software more in the cars, not just only in the middle console, in the
head unit.
In the head unit, but also in the deeper systems. And why is that? Well, cars shall not kill people, okay? And so there is actually in the automotive industry, there's this effort of getting to zero death. So this is a poster from Africa, and they have posters all over the world, like South America, North America, Asia, Europe, different problems. But the tenor is, with intelligent cars, we can solve this, and we can solve this hopefully. And so a car is transforming into being like a mobile on wheels, and a smartphone on wheels actually. And you expect it to be like that. You expect it to be current, up to date with software. And how do you get that going? And so the open source community actually has a lot of experience with that, you know. So getting security updates out, Debian does it, OpenSUSE, Fedora, and all the enterprise Linux distributions. So they get the time from, we identify a bug in the open source community, we get it to the people doing the base operating system, we get it to those integrating it with functions, we get it signed off with the vendor, and we get it out, you know. They get that done within something like 2, 3, 5 weeks. And the automotive industry goes like, well, a software update, we do it every half a year at most. And there are reasons for that, like the winter drive and homologation. So in the project that we're currently working on, we have to have things ready before winter, because then they're built into a car and driven around all over Finland at minus 30 or minus 40 centigrades to show that the software works. And, so we also have these processes like SPICE, right, where we said we have this waterfall model. And then there is the OCIDL, where automotive vendors try to get the kernel approved for safety functions in the car. And the idea is you look at the kernel process, the kernel development process, and you realize each of these things is actually done in the kernel community. It's just the chronology. They don't start with a design. They start with what do we need, and then they dig into implementation and rough sketches and napkins and let's discuss this and toss forth and back. And then at the end, when you look at patch series, everything is in there. In the patch series, there's why do you want to do it, which systems are touched, how do they interact, and then everything is formally specified in the ISO-defined C specification language. I love it. So, and then in the cars, what's also happening is that they move together all the semi-smart control units. They move together all the intelligence into very few central ones. Only the airbags and such really life-critical things, they remain self-contained and interconnected in an own network, and all the rest actually moves the intelligence into central computers, and the sensors and the actuators become less smart and cheaper, because I mean you buy a car some million times or sell it. So if all these yellow ones become cheaper, then the whole car becomes cheaper, and that means that you need to create virtual ECUs inside the complex one. So you have these systems on a chip. The SOCs, and where you consolidate safety-related stuff and classic, the automotive operating system, and then Linux systems with an open source hypervisor. And well, I didn't know before I joined them, so I worked with a Linux company for years, and then I joined the automotive industry something like 3/4 of a year ago. And what I didn't realize before was that companies like Continental, they buy more chips than anybody else and build it into something. So getting open source, this is, for example, this is also from OCIDL, how do we get safety into Linux, functional safety into Linux, make lives depend on Linux. And doing this is a struggle at all ends, but it's fun. So thank you.
Thanks for your attention.
Do you have questions? Yes?
Hi. There's been a lot of industry standardization going on around Linux and automotive for about a decade now. Do you think Electrobit or Continental will join some of these open projects?
Oh, we are.
AGL?
So Electrobit is actually member of. Yeah. So the question was if Electrobit wants to join. Good question. So the question is if Electrobit would join AGL and start to contribute code. So or Continental. So actually Continental and Electrobit are members of AGL and members of JNEV. And
of the Linux Foundation as well. Linux Foundation as well.
The Linux Foundation. And when it comes to contributing code, we have one first patch upstream in the kernel with an Electrobit email address.
No, it's even 4 or 5 already. It's 4 or 5.
4 or 5 meanwhile. So it's slow. And as I said, I mentioned the legal part. It's we need brains inside the company who help us propagate the idea, and we're working on it. Thank you. There's a thumbs up for the guy who asked the question. Yeah.
You said that with the GPL3 license, you have the right to get the source code from your car steering. Then you said, what happens if the mechanic changes the program in your car
Yeah.
versus you does not say that the mechanic has the right to change your car.
GPL3 does. GPL3, and this is so. The question was, GPL3 only forces you to provide the source, but not to modify. Be able to modify. GPL3 has an anti-turbalization clause, which requires you to be able to deploy your new software into the device that you bought.
You can do it.
Huh? Yeah, that I can do it. Yeah, I get this, and that's a problem. So thank you very much. Time is out. Yeah, bye.
Thank you. Bye.